Okay, welcome back to school for the new year. We're going to start with lesson 43, periodic functions and graphs of sine and cosine functions. Now, we've graphed some other functions before. We know how to graph the linear function, a quadratic function, and exponential function. So this is the first time we're going to graph a trigonomic function. Now you can see the graph over here. This is the graph of a sine function, and you see how it repeats? It has repeating patterns. It's just going to go up and down and up and down over and over again. If it has a repeating pattern, it's called a periodic function. A periodic function. So a period would be from here to here would be one period, and then it just keeps repeating and repeating. And you know that because a sine, when we did the unit circle, we have a circle. So we'd have 0 here, we'd have 180 here, and then it would just keep repeating and repeating. And the highest it ever goes to is 1. So on our sine function, it'll go to positive 1 and to negative 1. If you do a sine of any angle, it's not going to be greater than 1, and that's why the basic sine or cosine function only goes to 1 and negative 1. Now you could just plot the points. If we make this axis, instead of being an x-axis, we make it theta, and this would stay the y-axis, we can just plot the points and you'll see that we get a curve. Like, you know, if you put in your calculator, if you don't even want to figure it out, the sine of 0 degrees is 0. So we have a point at 0, 0. The sine of 30 degrees is a half. So here would be like 30 degrees, and that would be a half. The sine of 90 degrees is 1. Sine of 180 degrees is 0 again. The sine of 270 is negative 1, and then when we get back to 360, that's the same thing as the sine of 0 degrees, so the whole thing starts repeating again and again and again, whole way out to 720, whole way out to infinity, it repeats. So this is your basic sine function. So let's look at some down here. Here we have, this one's a little bit better. We have this, here's a sine function out to 360, and if we put a negative sign in the front of it, see this? It just inverses the whole thing, so it just makes it all, instead of going up first, it goes down first. So that's how that works. If you just put the negative sign, it just reverses it. Now a cosine function is also a periodic function, and it's the same thing, only if we found the cosine of 0, we would get 1. The cosine of 90 is 0. The cosine of 180 is negative 1. The cosine of 270 is 0. The cosine of 360 is 1. So you can just see it's going to keep repeating, but the cosine starts at 1, and the sine function starts at 0. So they're the same thing except where they start. Now, a little bit more about this. We're going to be doing these functions for quite some time here and there in the book. You know how that works. We can also change the amplitude of a function. This right here is the amplitude. For some reason I'm not writing. There we go. This would be your amplitude. The amplitude. It's how far it rises from the center line of the function. Rises or falls from a center line. Now, in another lesson this week, we're going to talk about the center line, how we can move it up and down. But for right now, we're just going to change the amplitude. Right here, the amplitude is 1. Down here, the amplitude is 2. And the way you change the amplitude is you just multiply the sine function by 2, and that would be the graph of 2 sine of theta. And if we did negative 2, this is the cosine function, so cosine function doesn't start at 0, the cosine function starts at 1, and instead of multiplying it by just negative 1, where we flip it, it's multiplied by negative 2, so it flips, and the amplitude becomes negative 2. So let's try a couple quick examples, and then we're going to be done. This is lesson 43. 1 second. Okay. What your homework's going to be like is you have to find the equation, and they call this a sinusoid, which is just a curve, a graph shaped like a sine curve. They call it a sinusoid. Even if it's a cosine, they call it a sinusoid. So if we look at this one, do you see how it starts at 0? So we know it's going to be a sine function. If it started at 6, well, let's just not get into that now. So it's going to start at 0 and it's going to go up and down and up and down. So we would just write for our equation, we just write y equals, now we have to check the amplitude. The amplitude is from the center line, it goes up 6. So we just say 6 sine of theta. And that's how easy these problems are. Let's do the last one and then we're done. Write the equation for this sinusoid. Now this one, instead of starting at 0, it's starting at -3. So this is actually a cosine curve. So we would write y equals, and we're going to check the amplitude here. Now you're going to notice, see how this is pi over 2, pi, 3 pi over 2? That's just a different way of writing the angles. It's written in radians. So pi, remember, is 180 divided by 2, so this would be 90, 180, 270, and 2 pi is one period long, so that would be the 360. So your amplitude is 3. And you see how it's starting at in the negatives instead of just at the positive? A normal cosine function would start at 1, right? If we had a normal cosine function, it would start at 1, and then it would go down and then up and down. It would just be a little smaller version of that. So what happened is this is flipping. So it's going to be negative. The amplitude is 3 cosine of theta. And that's all there is. Or you can say the cosine of x. This graph, you can't really see it really well. It has an x there. So that's why instead of having the theta, they have an x there. And that's all there is for lesson 43.